So we've taken a look at continuous functions and what it means to be continuous at a point. The next thing we want to take a look at is what happens when we try to combine some continuous functions. And so we have just a couple really quick theorems that we're going to look at. We'll look more at continuity in the next chapter as well. But here let's finish up, let's close out this chapter looking at just a few quick items that I think most of us have maybe an intuitive understanding of that these things are true, but let's just formalize that in theorems, right? So if f and g, if these are continuous at this point C, they have the same domain, same codomain, their functions. C is a point that is a value in that domain. Then when you add the two functions together or you multiply those two functions, the product or the sum of the two functions is also continuous at C, right? So it's a continuous, the sum and product is continuous at C if each of the original two functions were continuous at C. If we were to divide the two functions, it's continuous at C as well, provided that that function value of g when evaluated at C was non-zero, right? Because if it was 0, we would be dividing by 0, and that's problematic. So we have those things that are true when we combine functions. We also have, we can think about compositions of functions. So if f has a domain D and maps to the real numbers, g has a domain E and has a codomain of the real numbers. These are both functions, and the range of f is a subset of E, right? So our range of f here is a subset of E, right? So it's a subset of the domain of G. If f is continuous at a point C and D, and G is continuous at that point G of C in E, then that composition of functions, that composition has to be continuous at C. So let me maybe just jot a couple things down here real quick, right? So notice that this is G of f of C is what we're thinking about here. So we're starting here, so this point C is going to be enacted on by f. So we have the function f evaluated at C. So that value C has to be in the domain D in order for the function f to make sense. The output of that is going to be a subset of E. So this is an element, f of C is an element of E. So it makes sense to apply the map G to f of C. And G was if G was continuous, then that composition has to be continuous. So the final output is still in the real numbers. Beautiful, right? So those are a couple quick rules about continuity of compositions, sums, products, and quotients of functions that were already continuous. All right, we'll talk to you guys again next time.